So what we have done last time was we created a random model and we got the log loss around 0.88. So with a random model we have 0.88. Now what we are going to do in this section is that we are going to create different other models, and in fact what I would be working on is mainly logistic regression, linear SVM and XGBoost. Why not other like random forest? Because remember, this is a huge dimensional data. We do have like almost 790 columns, which is huge. So the other algorithms may not work well, but I leave it as a homework activity again for you to basically apply them up and see if you may get a better result. Let me also know. But most likely this is not going to work well, so and it will also take a lot of time. So that's the reason we are sticking towards techniques which towards algorithm which basically are going to work well with higher dimensional data. So let's start with logistic regression, and here we are also kind of doing a lot of hyperparameter tuning. Now you can see that we have put a lot of comments for understanding all this part, and here we are going to choose an alpha. So this is going to be an hyperparameter. So we're going to take multiple values of alpha and going to run our algorithm. So you can notice that I'm using a log loss of log, which means that I'm using a logistic regression. Secondly, I'm using the L2 regularizer, and basically I'm running it for all the alpha values of I. Right. So now when I'm going to run it, remember it's a log loss, and we have learned that if whenever you have to work on log loss, it is always you have to use calibrated classifier so that you can convert anything to a probabilistic format, because remember log loss always require probability. So we are going to use it, we're going to fit the model, predict the probabilities, and this is what we have done for it. Now if you notice, my log loss is coming minimal for this value, which is with 1, and we have also plotted it up. And if you notice, this code is very similar to what we have seen in medical treatment also. There is nothing too special about it. So now you can see that with this graph also, that at the value 1, this is kind of at the minimum part. So now what we will do, we will look at the log loss at the train and the test, and you can notice that both this log loss is coming quite close, which means they are not overfitting. So they are not overfitting. This is what we are. But can I really say this for underfitting? No. Now, if you look at it, we got almost like 0.52. Now, ideally, I should have got near to 0. And this was my random log loss. And I have come somewhere around 0.52. This is not great number, right? I could have come somewhere around 0.3, which would have been far better than this. So since I'm getting around 0.52, there is a chance that maybe my logistic regression might be underfitting, and that's the reason this is giving me this part. Remember, logistic regression have a problem of bias. So you can go with high bias if you are using logistic regression, and that's the reason we have to look at this thing. So what we will do, we got logistic regression which is taking us to 0.52. Let's see if we can get a better number with SVM. But before that, I want you to also notice one more interesting fact here. If you look at the precision and recall, definitely my precision is looking okay, not a big issue. But if I look at my recall, there is a big problem. So this is fine, but this is not fine. Because if you look at it, I am misclassifying almost like 50% of my point, which is definitely a big no-no for me, right? Big no-no for me, because this is a big huge concern. More than 50% of the data we are misclassifying here for class 2. For class 1 we are very good, means definitely this is a very good number, I would say. But the second part is definitely basically a big concern for me. So let's see if my linear SVM is going to help me solving this problem. Now again we're going to apply linear SVM for the hyperparameter tuning. Now same thing, we gonna apply the calibrated classifier. You can see that I'm using this time the penalty as L1, not L2. I'm using the hinge loss, but feel free to change it to L2 and see that what's gonna happen. Now after that you will again do exactly the same code, and this time your log loss is coming minimal here, 0.48, right? And if you even try to infer it from the graph, it looks the same, right? Now let's look at the log loss values. So now we got to this number. This is better than last time, but definitely this is also telling me that we are not overfitting here as well, right? So this looks good. So this is not overfitting. Now let's note down this number here also. So with linear SVM, we are coming to 0.42, right? 0.48, sorry, 0.48. Not a great improvement, but okay. So again, we can notice that there is a chance of overfitting even here, because this is not a great number what we are also getting. Now let's look at the precision and recall. Maybe is that improving for us? Then maybe we can say that, okay, fine, we can still be okay with this model, but we have to first go and see that. Now here, when you see this number, again we have so many of the misclassification. This is awesome, even working better than your linear SVM, but this is a big concern. Okay, so again, my linear SVM also have a chance of bias, so this can also be an issue for us. Now what is the next solution? Next solution is looking at XGBoost. Let's try that. Now here I have not done much of the hyperparameter tuning. I would like to leave it to you to do that, hyperparameter tuning. So I am having all these values, max depth and everything, and we are passing all these values, creating the matrix, and we are calculating the log loss after training all the model with XGBoost. I need not explain this code because you are quite familiar with XGBoost by now. So you can also write it in a different way, which I have shown you in the class as well of machine learning course, but feel free to use it in whatever way you want. I've just keep on playing with different syntax here and there. Now, if I look at my basically these values, so what is the output? So definitely this is doing a lot of iterations, and remember 790 is an okay data set for XGBoost. Maybe if you have 10,000 columns, then XGBoost may not work well. So keep that in mind. And XGBoost also have a big problem that it can overfit a lot of times. Okay, so you have to be little cautious with XGBoost at that point. Look at my log loss. 0.3435 and the training loss was 0.34. Look at this number. This is a wow for me. So this is the part, and this is my test log loss, right? So looks like this is also not overfitting, which is quite good, right? Because XGBoost have a high chance of overfitting, but looks like this is not overfitting. Secondly, this number is now coming to 0.34, and remember, I told you this point. If we would have come somewhere close to this, we could have said that it's a good model, because now it is quite far from 0.88. On the other hand, any number close to 0.5, I cannot really say that it's too good from the random model. So now this XGBoost is definitely working better in comparison to last one, but definitely remember we have to look at the precision recall also to basically make sure that we are not doing wrong. This is okay. Now this is not 0.5. This is 0.3, which is okay. So looks like we have improved, and this is still excellent. So we have now improved and got this particular solution, and now we can say that in this case we can particularly choose XGBoost to basically build this model. Now I would say that please go ahead and build with other classification algorithms what you are aware of, and see that whether they really give you better result than this. I have already done a lot of experimentation on this code, and trust me, they are not going to work better. But still, I would like to see if you can come up with something interesting. Means except neural network. I'm not going with neural networks because that is not being taught yet. This will be a deep learning topic. But whatever you have learned from basically from the knowledge perspective of basically for you for machine learning, then I would like you to apply. So this is the solution for Cura project.